going on, everybody? In this video, I'm going to talk about the domain of functions. So most of the functions that you're going to be dealing with, the domain is going to be all real numbers. You can plug in any value of x that you want, but there's a few of them that don't, and it has to do with the expressions that are defining the function. So I'm going to go through a few examples of these. These are typically your square root functions or rational functions because you could have values that would make the function undefined or not a function anymore. You could have more than one output for each input. So I'm going to go through a couple of examples to show you what I mean by this. So for the first example that I have f of x, the function of x, is equal to the square root of 25 minus x squared. So what do we know about the square roots? If we're going to be talking about x in the real numbers sense, we know that we cannot have a negative number or a negative value inside of the root when we're talking about real numbers. So because of this fact, I know that if I have something in a root, then that thing inside the root is going to have to be greater than or equal to 0. So when I apply this domain restriction into the function that we have right here, I know that the thing inside the root, which is 25 minus x squared, has to be greater than or equal to 0. So and then you just solve the inequality for x and see what you end up getting. So I have that 25 is greater than or equal to x squared. And when I take the square root of both sides, I have that x negative 5, x is less than negative 5, and I also have that x is less than or equal to 5. So to test which of these intervals is valid, I have to draw the number line and mark my values of negative 5 and 5 on the number line, and then do the test intervals like we did when we talked about inequalities. I'm just marking these with different colors to provide some distinction. So if I pick a number that's below negative 5, I'm going to pick negative 6 and see if the inequality holds true. So 25 minus negative 6 squared, and I need this to be greater than or equal to 0. In other words, a positive number. So I have 25 minus 36 is greater than or equal to 0, and it says that negative 11 is greater than or equal to 0, which we know is a false statement. Negative numbers are less than 0. So I know that I'm going to get a negative value inside of this interval, which means that it is not valid. So if I'm going to pick a value in between, in the green interval here, I'm going to pick x is equal to 0 because that'd be easy to evaluate. So 25 minus 0 squared is just 25, which is obviously greater than 0. So this one checks out. We're going to have positive values in the middle here. So this checks out. And if I'm going to test a value right here of x, so I'm going to say x is equal to 6, 25 minus 6 squared just gives me that negative 11 again, which is not greater than 0. So this one is out. It's going to give us negative values, which means that it's not valid. So the domain is just going to be the interval from negative 5 to 5. And since this has a greater than or equal to sign, we know that the endpoints are going to be included. So I can say that the domain is the interval from negative 5 to 5 with brackets, closed interval. So in the second example that I have h of x is equal to x divided by x squared minus x minus 6. So notice what kind of function we have. We have a rational function here. And the thing that we know about rational functions is that any value that makes the denominator 0 makes the function undefined. So we have to exclude those values from the domain of x. So to find these values, what we have to do is we have to take our bottom part, the denominator, and set it equal to 0. So I've got x squared minus x minus 6 is equal to 0. So this one factors into x minus 3 times x plus 2. And then when you go to find the zeros, just set each of the factors equal to 0. You get x is equal to 3 and x is equal to negative 2. So since these are the values that if we plug it in to the bottom here, we get a 0. It makes the function undefined. then the domain is going to be all of the x values that are not these two values. So the domain is that x can be any real number besides -2 and 3. So there's a lot of different ways that you can represent this. If you want to represent this as an interval notation, you have to include all the numbers that are not 3 and -2. So the way that you do this, you have domain x is equal to -infinity all the way up to -2, not included, union, -2 all the way up to 3, not included, union, and then 3 to infinity. Every number besides -2 and 3. So this is just a couple of examples with functions that have domain restrictions, but I want you to get the idea. Analyze what type of expression is representing the function, what describes the function relationship, and what do I know about that type of expression. What x values can you plug in? Which ones can you not? How is my pool of x values that I can input restricted by what I see on the page? That's the main answer. That's the main question that you're trying to answer when analyzing the domain. So I hope this video was helpful, and stay tuned for the next one. Take care, everybody.